Let's go! Number 5. Quantum immortality. This sounds like science fiction, yet some physicists will quietly admit there's a version of quantum theory where you never experience your own end. The seed gets planted in 1957 when Hugh Everett writes down what becomes the many worlds interpretation. In plain English, every quantum coin flip splits reality into multiple outcomes, and all of them continue like parallel timelines that don't talk to each other. Now take that and add a brutal thought experiment that shows up in the late 20th century in different forms. A quantum device triggers a lethal event based on a genuinely random quantum outcome. In a single world picture, that's the end. In a branching picture, there are timelines where the random event goes the other way. The trigger is set by quantum measurement, and in a many worlds view, each possible outcome continues in a separate branch of reality. Here's the eerie part. You don't get to watch the branches where you're gone. You only ever wake up inside branches where you continue. So, from the inside, your personal story feels biased, not because reality favors you, but because you can't observe the branches where you don't observe anything. It breaks the most basic intuition you have, that you're riding one timeline that eventually stops. This idea says your subjective experience might be trapped inside one quantum reality, like a camera that can only keep recording when the battery somehow never dies. The theory explanation is basically this. If quantum device never decides the outcome, and all outcomes happen, then you becomes a bundle of versions. In some, the coin lands the bad way. In others, it doesn't. Quantum immortality is the sci-fi flavored claim that your awareness only ever tracks the versions where you remain aware. If this theory was true, it would rewrite how you think about risk. You could survive impossibly many close calls, not because you're lucky, but because your perspective can't land in the dead ends. It turns survivor stories into something darker. Not you beat the odds, but you only remember the branches that still have a you. But here's why it doesn't settle anything. Quantum immortality depends on many worlds theory, which is not experimentally confirmed as the unique answer. It also runs into a brutal question. Even if branches exist, why assume you must continue in any meaningful way? Identity might not follow continuity the way the story wants. Some physicists argue the whole immortality framing is a misleading trick of perspective, not a physical promise. Still, if the branching picture is real, the implication scales up hard. Your life could be a narrow hallway through an infinite mansion of outcomes, and you only ever notice the hallway you're still walking through. So here's the question. If reality keeps splitting, are you living one life, or just the only version of your life that can still ask the question? Number 4. Quantum wormholes through black holes. This shouldn't be possible. Yet the math of gravity and the math of quantum information keep hinting that space might have secret tunnels stitched into it. The story starts in 1935 when Albert Einstein and Nathan Rosen describe what we now call an Einstein-Rosen bridge, a wormhole-like connection that shows up in the equations of general relativity. Back then, it's not presented as a sci-fi subway. It's more like a strange feature of the geometry, mostly not traversable, mostly a warning sign in the math. Fast forward to the modern era. In 2019, the Event Horizon Telescope collaboration releases the first image of a black hole's shadow, the supermassive black hole in the galaxy Messier 87. Then, in 2022, they show the shadow of Sagittarius A star at the center of our own Milky Way. Not a drawing, not an artist's impression. Real data stitched together from radio telescopes spread across Earth. Now the quantum theory part. Some physicists propose that quantum entanglement and wormholes might be connected. In 2013, Juan Maldacena and Leonard Susskind push a famous idea often summarized as ER equals EPR. The translation is this: an entangled pair of particles isn't just mysteriously linked. The link might literally be a tiny, non-traversable wormhole in the geometry of spacetime. It's a conjecture, not a proven tunnel you can fly through, but it hints that entanglement could be the glue that helps spacetime exist at all. Why it's weird is that it turns space from a fundamental thing into a property. The rule it breaks is the intuition that distance is fundamental. This line of thinking says distance could be emergent, like an illusion produced by how information is stitched together. Real-life implications are huge. If space-time is partly built from entanglement, then the far-future engineering wouldn't start with engines. It would start with information. In the most speculative visions, advanced civilizations might shape connections between distant regions by controlling entanglement networks, ultra-secure communication, quantum teleportation links, maybe even new ways to stabilize exotic space-time structures. None of this is near-term, and the wormhole part is debated, but it gives you a chilling idea. Geometry might be hackable in principle, but none of this is settled. Wormholes that are stable and traversable typically require exotic conditions, but it's not proven in the way a lab measurement is proven. And black holes are still the arena of the information paradox, the fight over whether information is destroyed or preserved. Still, if this is true, the implication is haunting. Space might be less like a grid and more like a network, and black holes might be not just holes, but knots. So here's the question. When you look at a black hole's shadow, are you seeing the black hole or a hidden shortcut in the fabric of reality? Number 3. Entanglement as telepathic communication. This seems impossible. Yet for a century, quantum theory has offered the temptation. If two things can stay linked across distance, why not minds? The story begins in 1964 when John Bell shows how to test a simple question. Are entangled particles just carrying hidden instructions? In 1982, Alain Aspect runs experiments that strongly favor the quantum answer. Then, in 2015, a team in Delft, led by Ronald Hansen, links electron spins in diamonds about 1.3 kilometers apart and runs a loophole-free test. The result: particles correlate between each other with values too strong to explain with any ordinary physics. Whatever is happening, it's not just secret notes carried from the start. What happened, in the cleanest visual terms, is this. You create a pair of quantum particles. You separate them. You measure each one in ways that should not be able to coordinate if they only obey normal signals. And yet the statistics line up like they were connected the whole time. So why can't that be telepathy? Because entanglement in current physics view gives you correlation, not control. The outcomes, they are more like two matching lottery tickets you scratch at the same time. You can't force your ticket to be happy and make the other ticket read happy. You only find out what you got, and only later, when you compare notes through normal communication, do you see the match. But if we stretch the idea, maybe twin brains, or people who are deeply bonded, could share some kind of entangled substrate. Maybe the feeling arrives before the phone call. Maybe the mind has a quantum channel we haven't measured. That would be a sci-fi explanation for those eerie coincidences that feel like someone was thinking the same thought at the same time. But here's the hard honesty. There is no robust evidence that brains maintain useful long-range entanglement for thoughts, especially in warm, wet, noisy biological conditions. And even if some quantum coherence exists in biology, it does not automatically become telepathic messaging. The physics blocks controllable faster than light communication in standard quantum theory. So as far as modern physics goes, it's not mind reading, it's sync without signals. Entanglement is like a perfect shared secret key. It's the dream of unhackable coordination. It's the seed of a quantum internet. It's the reason quantum cryptography exists. It's a kind of connection, just not the kind sci-fi movies promise. Yet, if we ever found a way around that no-control barrier, if a new layer of physics allowed steering entanglement outcomes, the scale-up is terrifying. It would mean new channels through reality. It would mean causality itself is negotiable. So here's the question. If your strongest intuition about someone feels instant, is it just a thought? Or are you sensing a deeper correlation you don't have words for? Number 2. The elitzur-vaidman bomb tester, detecting without touching. This shouldn't be possible. Yet in 1993, Avshalom Elitzur and Lev Vaidman describe a setup where you can sometimes detect a live bomb without detonating it. And the key phrase is sometimes, because quantum gives gifts, but always charges a fee. The instrument is a simple interferometer story. A beam splitter sends a single photon down two possible paths, then mirrors bring the paths back together so they can recombine. Depending on whether the two paths stay perfectly aligned, the photon's wave behavior can cancel one exit completely, making one detector effectively impossible. A single photon enters and faces two paths, like a fork in the road. If both paths are open and nothing disturbs them, the wave nature of the photon makes the paths interfere so perfectly that one detector never clicks. It becomes the impossible detector, a locked door. Now place a supersensitive bomb on one path, a bomb that explodes if a photon touches it. Suddenly, the interference can't form the same way because one path is blocked by danger. And here's the moment that feels like a glitch. Sometimes, the photon triggers the impossible detector. No explosion, yet you now know the bomb is there. You learned about the object's presence from a result that only happens when the object was present, even though in that run, the photon did not set it off. That breaks the intuition that information requires contact. It feels like gaining knowledge for free, like checking a trap without touching the tripwire. The theory explanation is that quantum systems don't travel like bullets. They have probability amplitudes that interfere. By arranging interference so that safe world always routes photons away from a detector, you can make the appearance of a click become a sign that something disturbed the interference, which in this setup means the bomb exists. Real-life implications are deliciously cinematic. Imagine scanning fragile artifacts without shining harmful energy on them. Imagine checking whether a sensor is live without triggering it. In more practical physics terms, this becomes interaction-free measurement and quantum interrogation, ideas that were developed further in the late 1990s by Paul Kwiat and collaborators, showing you can reduce the chance of triggering while still learning the presence using repeated gentle checks. Some physicists debate how interaction-free it truly is, because the whole setup relies on the possibility of interaction, and the environment and apparatus do the heavy lifting. And in the basic version, you still sometimes blow up the bomb. Quantum gives you a way to win sometimes, not a guarantee to always win. Still, scale it up, and it becomes a philosophy grenade. It suggests reality contains information channels that are not intuitive, that not happening can still shape what you learn. So, here's the question. How much of your knowledge comes from contact, and how much comes from the paths you never took? Number 1. Quantum consciousness. We saved best one for the last. Some researchers keep returning to a taboo thought. What if consciousness is not just chemistry running on biology? What if it uses quantum rules in a way that matters? The most famous modern proposal is tied to Roger Penrose, who in 1989 argues that human understanding might involve non-computable physics. Later, in the 1990s, Penrose and anesthesiologist Stuart Hameroff develop a theory that's called orchestrated objective reduction, or ORC-OR, proposing that quantum processes in microtubules inside neurons play a role in conscious experience. The discovery moment here isn't a single lab clip like a black hole image. It's a long argument across papers, critiques, and counter-critiques. In 2000, physicist Max Tegmark publishes a critique arguing quantum processes in the brain would be too fast, on the order of extremely tiny fractions of a second, crushing the possibility of useful quantum computation in microtubules. Then, Hameroff and collaborators respond in later work, arguing the estimates depend on assumptions and that these processes could be longer under certain models. The debate becomes a mirror of the bigger problem. We don't yet have a complete physics of consciousness, and quantum theory is the most tempting mystery box we own. Classical brain stories say thoughts are patterns of electrical spikes and chemical signals. Quantum mind stories say there is an additional layer where the brain might preserve or orchestrate delicate quantum states long enough to influence cognition. This idea says consciousness might involve physics that is deeper than computation, deeper than neurons as switches. And if it's true, then your mind wouldn't just process reality. It might sample possibilities in a way that's closer to quantum decision-making than classical calculation. This means enhanced intuition, but the grounded version is more interesting. New models of attention, memory, and the timing of conscious moments that could explain why existence feels seamless. If quantum consciousness were real, connecting to the universe wouldn't look like magic powers. It would look like your mind gaining access to a deeper layer of reality that most systems never touch. Imagine awareness as a kind of receiver that can lock onto patterns hidden inside uncertainty. The faint structure inside, that opens wild possibilities, moments where intuition isn't just memory and instinct, but a real sensitivity to how outcomes are about to settle. Meditation that feels like zooming out because your brain is syncing with larger-scale rhythms. Shared presence where two people align so strongly they predict each other like a single system. Even technologies that amplify that layer, turning focus into a tool, like a compass for probability, a way to steady your internal world when the outside one is chaotic. But here's the honest boundary. There is no scientific consensus about quantum consciousness. Neuroscience already explains a huge amount without quantum. Evidence remains incomplete. The predictions are not yet clean, decisive, and widely replicated in the way mainstream physics demands. And yet, if even a thin slice of this is true, then you're not just a passenger watching the quantum world from the outside. You're part of the universe. That would mean a thought isn't only neurons firing. It's a pattern that rides deeper constraints, information, uncertainty, correlation, the rules that decide what becomes real and what stays only possible. It would blur the line between in here and out there, because if consciousness touches that layer, then the universe isn't just something you look at, it's something you participate in. Maybe the mind isn't separate from reality. Maybe it's one of reality's built-in interfaces, one of the ways the universe turns itself into an experience. So here's the final question. If consciousness really is quantum, then when you look at reality, maybe reality is looking back? And that's the countdown. Click that subscribe button for more quantum stuff.